Okay, thank you, and I am out. Good afternoon. Today we're going to be talking about unlocking the future of rendering in VR using Unity's new scriptable render pipeline. At Unity, you know we're all about solving hard problems for our developers, and when it comes to gaming, one of the hardest problem areas is rendering. Our out-of-the-box render pipeline actually makes it really easy for you to create great content and deploy on a range of platforms from desktop to mobile. But what we've been finding is that some of our creators are having to make really hard choices, trade-offs between visual fidelity, performance, and explicit control over your features. Well, with the scriptable render pipeline, you now have full say in making those choices. And it's going to raise the bar on what we get to do in VR. I'm so excited to talk to you about it today. I'm Tony Parisi. I'll be joined in a few minutes by Brad Wires, my colleague, to run you through all this. But before we get started, let's watch a quick video. This project is called The Book of the Dead. It was created by Unity's award-winning demo team in Stockholm to show off the features of the scriptable render pipeline. We built a high-def render pipeline on top of scriptable render pipeline foundations. And what you're seeing here, it's worth pointing out, it's probably obvious, but in case it's not, that is not a film. That is 100% CGI rendered in real time on a PC in the Unity engine using the high-def render pipeline. And if that wasn't amazing enough, we have this running in VR now in an Oculus Rift where you're in the middle of the action and you can move around and interact with it. And so that is so exciting, and we're going to go through all that in detail today. So here's our agenda. First, we're going to talk about the challenges of VR rendering and the state of rendering today in Unity and what the foundational issues are that motivated us to create the scriptable render pipeline. Then we're going to provide a brief intro to that and then do a deep dive on the high-def render pipeline for fidelity, like what we did with Book of the Dead, and a lightweight render pipeline for speed on mobile. Then we're going to go through some authoring tools and take you through the product roadmap for the next little while and tell you how to get started with resources. Okay, so let's do it. So for the programming inclined in the room, if you are Unity devs, you're probably familiar with this already. We actually have two ways of doing rendering, two basic, what we call render paths: forward rendering and deferred rendering. Forward rendering is sort of the classic one that most of us use. We know really well. Under the covers, what's happening is you're drawing your objects, you're lighting them as you go to create the final rendered image. With deferred rendering, you actually do a draw pass into multiple textures, what we call buffers, and those textures are combined at the end to create the final pixel result. The reason you pick between either of these two techniques is based on what you're trying to do. With forward rendering, it takes advantages of most of the sort of graphics hardware that's out there, the features of most of the graphics cards today, to do things like anti-aliasing to take out the jaggy edges. But it's really limited in things like the number of lights you can use. So what you do as a content creator, if you're doing forward rendering and you want more lighting and great effects, you'll do things like bake your lights into light maps. And so that's all pre-baked, and that all works great unless you have dynamic lights in your scene. Things flashing, moving around, being added and removed on the fly in your scene. So if you want that kind of stuff and want to have high performance with it, you go to a deferred rendering model. But deferred is very limited in what it can do too. So it gives you lots of lights, takes care of all that. But you can't take advantage of some of the great things you can do like multi-sample anti-aliasing to make your scene look really smooth. Or in fact, in Unity, you don't do any transparent rendering. So if you have transparent objects, you're basically out of luck. So those are the trade-offs there. But the thing with Unity is you can pick that, make that decision up front, and literally check a checkbox in the editor and get one or the other. And all the shaders, based on the standard Unity shader, just work. And this supports all of our target platforms out of the box, all the hardware. So that's real good, but there are some foundational problems that have motivated us to develop SRP, Scriptable Render Pipeline. First one is discoverability. You have no idea. If you're a developer and you want to optimize, you have no idea what's really happening under the covers. You've literally just checked that checkbox. And if you know how to program a shader, you can dig in and sort of see what's happening, but it's really, really hard to understand what's going on. The second is complexity. I mean, it's really hard to configure this thing right. And if you want to go do it with some configurable options, there's ways to hook in to our render paths. You're basically twiddling knobs, and you kind of, you twiddle knobs till you get it right. You don't have a real sense of empowerment there. And then finally, flexibility. It's really not designed it won't do what it's not designed for, right? So the reason there's so much value in the Unity engine is we take care of these problems. We thought through the typical ways people want to render their scenes, what they need in terms of features, and that's the value. But if we haven't thought of this stuff before, you're not going to get that feature in there. Well, with SRP, we've changed all that, and you're going to have control over all of this. So that really is based on some root problems that we're going to go through right now, and the really ugly trade-offs here. And they're more pronounced, by the way, in VR. And why are they more pronounced in VR? Well, first of all, we know we need high FPS. We have to hit 90 hertz on a desktop system, 60 hertz on a mobile system. Resolutions are going to get higher and higher. The more we go for realism in VR, we're going to go to 8K displays and more. All that goodness, try that once per eye with 2 eyes. So now you basically really have to render like the blazes. And the more realistic our scenes are going to get, the more complex that data is going to get. So you need to have control and hooks into all this stuff. And finally, consequences. We know we need to keep frame rate up. We know we need to keep interaction high to have the best user experience. So these things all, we wanted to do really high quality cinematic rendering in the Unity engine, and the high def render pipeline is there for that, but it's even more needed in VR. All of this can kind of be summed up. I don't know if you remember this John Carmack quote from a few years ago, but basically he was still looking at VR content that had jaggy edges in it because people wanted to take advantage of some of these features like deferred rendering. But if you did the deferred rendering, you wouldn't get multi-sample anti-aliasing, so you basically get these crappy jaggy edges around your objects. And so you'd have to choose between which one of these things you wanted. Well, that isn't really much of a choice at all, is it? In addition to that very basic, not pleasant trade-off, the reality is that no two experiences have the same requirements, whether you're doing a shooter game or an art creation package or an industrial application like for a car or architectural walkthrough. Even within those categories of applications themselves, you might want to have more control over everything you're doing in that render pipeline, depending on exactly the effects you're going for, and whether it's more important to have high interaction, visual fidelity, or whatever. Instead of letting the Unity engine take care of that all for you and make a best guess, you can now make those trade-offs yourself. Okay, going to get a little technical for a second, but we don't really have to dive into too many details here. So you can hook into these two render paths right now. There are ways to dig in and basically customize the flow of this, but it's really not for the faint at heart. You're doing shader programming. How many people in the audience know how to program a shader? Hey, that's all right. That's pretty good. It's not fun, right? We all know it's not fun. I mean, the tooling is really hard for shading. The languages for shading are a little complex and not fun. You get the control you need, but basically it's not the best way to develop and design. It'd be much better if you could use user code like script code in C#, which we'll get to in a minute. So that's one of the biggest areas. And really, it's just these very specific places where you can hook into. You still don't really have control over the entire loop, the flow of your render loop, and that gets really interesting when you're able to do that. And last but not least, in terms of exploring the foundations of what we're talking about here today, if you are familiar with rendering, this is the way rendering classically works, and this is what we're completely blowing up with SRP. The way rendering typically works both in the forward and deferred passes is this. You call. Call means I'm going to get rid of objects that the user's not going to see. It's all based on your view volume, where the camera's looking. Then you draw. You've got a list of stuff now after you've called, and what you do is you'll sort it. You will batch it to make your materials efficient. You will do any transparency sorting for alpha, et cetera, et cetera. You get that image rendered, and then you post-process against the screen image before you show it on the screen with effects like blur and glow and all that. This is classically how it's done, and the data structures that support that under the covers are all set up for those kind of rendering techniques. But if you want to do something different, you are out of luck unless we give you a way to control the flow of the rendering pipeline. And that is what we're about to do, and that's why Bradley's going to come and talk. So Bradley Wires, my colleague, is the XR product manager at Unity, and he's going to do a deep dive now on the scriptable render pipeline in HD, and I'll be back in a few.
Thanks, Tony. So what Tony was talking about here in the previous slide is we have culling, we have drawing, we have post-processing. If we really think about it that simply, why not just unlock every stage of the pipeline so you can do anything? Here, at the top, we have our classic legacy render pipeline. That's fine. You can use that, and you'll still be able to use that for a while. But at the bottom, you have your infinite sort of possibilities SRP. So everything that we're going to talk about today is fully customizable. The SRP is really just exposing everything up to C# code, and we're providing 2 render pipelines that you can use and customize at will, and really you can build things off of and share with each other and know that other people will have access to those render pipelines. But as we're talking about the render pipelines today, I want you to keep in mind that though there's 2 main ones that we're really interested in, really you can do anything that your imagination and talent will kind of let you do. So the motivation, 3 of the key things when I was thinking about SRPs that are really kind of were behind why we did these was, 1, we wanted them to be lean. We wanted you to be able to write lean render pipelines. So lean means getting rid of everything that you don't need. If you don't have rendering in your experience, why have the code run that? Another aspect is configurable. So we want you to be able to go and change what's already happening. So if you don't like how one particular aspect of a render pipeline is working, you can change it and ship with that. Really the most exciting thing, I think, is that it's really user-centric. You can go into our existing render pipelines, see how they work, go behind the hood, pick apart, change, tweak things, see your changes. Or you can work with other engineers on the same render pipelines and customize for your experience. So the first one I want to talk about today is the HD render pipeline. The HD render pipeline is the sort of the high-end render pipeline. We kind of realized before with our legacy render pipeline that it was sort of this catch-all solution. We wanted to have the standard shader that would kind of work for whatever you were doing, whether that be console or PC or the lightest mobile device. And that essentially meant we had to make sacrifices in terms of what we could do on some of the high-end devices and the low-end devices. So HD is how we're rethinking things from a modern perspective. We have tons of people at the company who are really experienced with AAA rendering, really cutting-edge software and hardware that lets you take advantage of every stage of the rendering pipeline to get that pure look at the end that your creatives are looking for. And the 5 key aspects of the HD render pipeline are: 1, it's physically accurate. That means we work with Lux, we work with all the models that lighting in real life works with, we apply here. So if you have light settings that match maybe what a director is used to, how they set up lights in a scene, you can reproduce that in Unity and actually get pretty close. Another aspect is it's unified. Now, when I was getting my head around HDRP, I was kind of wondering, what does that mean, unified? Well, typically, how rendering works in game engines is everything is sort of, to make it real time, everything is sort of phenomenological, as they say, which is another word for hacked, really. What that means is if I need to do transparency, I'll kind of add that and figure out how that works and kind of tweak it until it looks like it fits with everything else. Translucency, same sort of thing. Reflection, I tweak and kind of tack it on top at the end. But here we've kind of taken from the ground up and created a model that everything is unified through. So lights, you won't get unexpected results no matter what you're doing, as long as it's within this pipeline. So performant means that we're actually taking advantage. We know what the hardware is that we're targeting. We're targeting high-end compute hardware, and so we can actually design our system around those aspects. And if you're going to do something specific on a specific piece of hardware, you could do something like say, okay, I'm going to target this exact graphics card and really tune it out at the end. So everything should be predictable. Everything should be configurable. That's our vision here. So I'm going to quickly take you through some of the features of HDRP. I'm not going to go too deep. My plan here is to get you really excited about what the possibilities are here and what the future is for our high-def render pipeline and SRPs in general. One of the first things is advanced real-time materials. Like I said, because we can kind of now step back and say, we don't need to support everything. We just need to support modern hardware. We can actually do things that would not be possible in a catch-all system. An example here is the image I'm showing here, which is glint and clear code. Now, these things would not be possible unless you, in fact, you would probably have to get the engine and change the source to be able to have this be possible. But now this is going to be possible out of the box with HDRP. You can see on this paint on this car, there's actually a material that's a sort of a clear coat and has little specks in it for getting that look that you only see when you look at car paint. Another thing is measured materials. So we have experimental support for AXF materials. That means scan materials. So if I'm designing something for, let's say, a car, and I've got that image up, that seems to make sense, I can go and scan the types of leather, the types of plastic that are in the inside, the paint itself, and make sure that my virtual creation, it actually matches one-to-one what it should look like in real life. Here's a couple of programmer art examples of some measured material. Here we have the glint and the clear coat on the left and some fabric on the right. So complex transparency and refraction. This is something that was not possible before. And this allows a lot of exciting possibilities like mirrors or windows that are half transparent and also reflect the world in them. And there's a ton of customization opportunities. So here we have an actual kind of a proper sphere reflection, and on the right, a plane-based one. So if you need something that's actually going to act like a mirror, you can do that. If you need something that's just a close approximation, you can kind of turn the dial down and do that. This one, this took a while for me to get my head around, actually, because all of our really kind of hardcore graphics engineers were so excited about this, and I kind of had to dig in to realize exactly why. Apparently, this new multi-scattering technique that HDRP has is a first for real-time engines across the board, and is actually one of the first for even offline rendering engines. What they've done is they've figured out a sort of a more general or a better model of how light should act when objects get really, I guess, really rough or really smooth, that you don't lose light energy. And so this is kind of some really exciting stuff. We have graphics researchers at Unity who will go to SIGGRAPH one day, and the next day, I'm exaggerating a little bit, maybe a week or two, it can be in HDRP. So these, I really wanted to share these with you just because these images were kind of blowing my mind. You can see we have two-sided rendering here on the bubbles. We have like transparent rendering there's things possible with transparent and reflective rendering that were never imaginable before. So this one is kind of exciting. These leaves look not bad. I think a lot of us would be happy with these leaves in our experience. But what if I told you with translucence, leaves could actually look like this? We have light kind of leaking through the leaves and going onto other leaves and self-casting shadows. This is also something that's possible with the render pipeline, and I think I'm going to just click through those one more time, show you the difference. On this next slide here, we have Yibing Zhang from Unity created this. She's calling it Wind Up Girl. It's a project she's working on, along with our graphics team at Unity. And you can see a bunch of the features together here. You can see hair, skin, eyes, the fabric on the sweater. These are all things that are unlocked with the advanced materials in the HD render pipeline. This one, this is blending and layered materials. And I don't know if anyone's ever tried this, but this wasn't possible before in Unity. Basically, what the team has done here is they would go out into the forest and scan different rocks and trees and get these great models, but at the end of the day, they wanted to put them together how they wanted to make them, like in the Book of the Dead demo. And so what I could do is I could take these individual photogrammetry scans, and I could start dropping them in moss and in sand, and you'll actually have the moss and sand mix with the material that's on the scanned object, which is really exciting. So they scanned a bunch of things in a forest around in Europe, and then they put them together and sort of designed a level with a path, and you can see the moss and sand mixing with the trees that it's placed on, so everything looks organic, and it looks like it was almost scanned that way. So lighting. This is something that would be 10 talks on its own, so I'm just going to shoot quick. The lighting is one of the biggest aspects of HDRP. It is the biggest aspect. There's the physical lighting that I mentioned before. So 1 meter in real life with lighting calculations, 1 meter in Unity. Everything should work the way you think it should, which makes it great if anyone's interested in learning more about how light actually works, or if anyone's doing research or wants to apply research to graphics in Unity. This is a great opportunity. In fact, I think even each one of these bullet points could be a talk in and of itself, so I'll let you go and explore this after we finish the talk. But if you look at what was possible with lighting in Unity before, there was a few light types, very simple attenuation, very simple settings. Now, sky's the limit. You can do anything you can think of with lights, really. Decals. So this is something I'm particularly excited about. Wish I could show you these things in action, but Decals basically lets you project a texture, like a paint splatter on the wall or anything like that, and move it around in real time and layer textures so you can get more complex looks. or spray paint in your game or anything like that. And this is also something that it was possible previously in Unity, but only in certain circumstances. Only, let's say, in the deferred rendering pipeline. And I think that's really one of the most exciting things. There's a lot of most exciting things in the HD render pipeline. But the really exciting thing is that we're sort of getting away from the idea of you having to worried about forward and deferred style rendering. We take care of all that under the hood. So there's full parity. You don't need to think about, okay, decals are in deferred, but I need MSAA from forward. We just take care of all that. Based on what you're using, based on what you're doing, under the hood, we go through the render pipeline in the way that's optimal for what you're doing. So if you didn't think there was a lot of features, if there was a lot of things you could do, I wanted to put this up quickly and call out some of my favorites. Shader graph support, we're going to talk a little bit about that. The distortion's amazing. Volumetric lighting. There's just so much here. And we're going to show a link at the end where you can go and kind of dig into this stuff in detail and go check it out for yourselves. So there's got to be a catch, right? There is a couple of things to think about, but we're also doing everything we can to mitigate any of the catches that are going to come up here. One big thing is SRPs are in preview until 2019.1. That means that if we find an edge case or something we need to change, it's still a bit of a moving target. So I recommend diving in and learning everything you can about it. But if you're starting something production, you might want to delay until 2019.1. Of course, it's never too early to start figuring it out. No shuriken particle support. So we might have support for shuriken particles, which is our kind of existing particle system in the future. But right now, we've actually got something really cool we're going to show you later for your particle needs that only works with HDRP. It's high-end hardware only. So we're talking about VR here, but we're talking about PC. We're talking about the console VR. But in the case of HDRP, in the future, we are going to start unlocking these features for mobile. But what you're going to want to think about for HDRP right now is the cases where you control the hardware, high-end hardware. We're talking about location-based VR, training situations. And so in a lot of those cases, that's really when you need the highest fidelity rendering. And VR support and HDRP are coming along together, and it's looking really nice. Like Tony said, we have Book of the Dead running in VR, which was just so cool to be in that forest. Your custom shaders that you've written in old Unity will unfortunately need to be redone. Now, that could be sort of a tough pill to swallow if you're really into custom shaders, but we're also giving you new options to write shaders that we're going to talk about later, so I think that should soften the blow a little. And so if you're really into asset store packages, for a little while, odds are that it probably won't have HDRP support, and if they use custom shaders, you'll have to do some porting work yourself. But in a lot of cases, I think it's worth a trade-off. I'm going to have Tony come up now and talk about the lightweight render pipeline a bit, which is just as important, I think.
That somehow made me sound like the technical lightweight, but that's okay, Brad, I'll take it. Probably true in this case. Worth maybe just reminding a couple of things. What Bradley just described with the high-def render pipeline, that is effectively an example, a very good working example that will ship as a package with Unity. But it is, even though all that stuff comes out of the box, it is not a black box. You can go and look at all that. And you can customize it all as user code. It is all C#. It's no longer mucking around in the shaders, right? So that is all key. And again, yes, Book of the Dead was built this way as well. And it's so great that it's happening in VR. All right, so let's talk about the lightweight render pipeline. The emphasis for the lightweight render pipeline is a little bit different. While you can definitely tweak your visual effects and do some of those kind of things, not at the level we're talking about with HD, the emphasis is really on getting the best performance for a mobile headset, because these devices simply aren't as powerful as the high-end graphics card-powered PCs that are out there, right? So all of our stuff already works with this lightweight render pipeline, all the built-in shaders and everything too. So like, similar things apply to what we had in HD. There's a lot of stuff that's just going to happen out of the box, and you can take this and use this lightweight render pipeline for mobile and get started and then start customizing it. So let's talk a little bit about some of the motivations here. Definitely performance first, intent to support everything out of the box in terms of the mobile devices and the standalones and the portable VR devices. And then its accessibility, it's very, very beginner friendly. So this is a much simpler shading system than I would think, rendering system than HD. I mean, I haven't personally looked at that code, so I don't know. But the idea is you can get in there and tear everything apart and play around there. So the goal, just to restate it, is to provide optimized real-time performance on performance-constrained platforms, right? So there we go. Performance over rendering complexity. So what is the catch with the lightweight render pipeline? It's about single pass forward rendering right now. We're not talking about deferred and some of these HD features. If you want real-time global illumination, you're not going to get it out of this one out of the box. Single shadow light caster, I won't go through every one of them. Like Bradley said, for HDRP, same thing applies. If you write custom shaders, and apparently half of you in the audience know how to write shaders, which I shouldn't be surprised at when we're talking about talk about the render pipeline, but it's still very impressive. You'll have to rewrite those, or if you're depending on asset store packages that have custom shaders, those will have to get ported. So this is an example called Boat Attack. This is actually coming with 2018.3, and you can grab the VR template and just start building it yourself for mobile. Is there anything else you wanted to say about Boat Attack?
I mean, I think Boat Attack is just a really exciting way to kind of go in right off the bat and start moving sliders around, start deleting code, see what happens, start adding code and see what happens. And so it was built for people to get in and do that right off the bat and see some kind of complex things that you can do in lightweight render pipeline. Because I think people were thinking originally like, well, why wouldn't I always want to do everything in, you know, I want all these cool features in HD. What if I want to do water? Right. And, you know, other really cool effects like, you know, kind of fake reflections and stuff. And so, you know, one of our engineers thought, okay, I'm going to prove that you can actually do a lot of this stuff in lightweight render pipeline and make it look good. Yeah, so this is going to be one of the first things you can get your hands on. We're going to give you a list of resources later. As great as an engine as Unity is, we're also all about enabling the creation, right? So we need to talk about tooling for a little bit here. So let's get started. We're going to first start talking about the Vfx Editor. It's a great way to create GPU particles. And this system is, when is this coming out? This is coming out in preview, right? 2018.3. Okay, we've got some fans for the Vfx Editor. That's great. And then let's show a quick supercut that Brad put together, actually, that shows what's possible with this. So the Vfx Editor is code-free. It's all node-based. The team that works on it is really familiar with all the other solutions that have been out there, whether those be you know, in-house at AAA game production companies or other commercial tools out there. And they've sort of had this dream for a long time, a lot of years now, that we're going to build this really accessible, super powerful GPU particle editor. And I think they've really pulled it off. You can go and download the 2018.3 beta right now and start playing with the GPU particle editor. And actually, in just a few minutes from just moving some sliders around, you can get some really cool things going on. Now let's talk about shader graph. How many of you shader ninjas love shader programming all day long and would rather just do it in source code than in a visual tool? Raise your hands. 3, 4 of you, all right. Now we're thinning the herd. Talk about culling, right? So let's talk about shader graph. It's a visual way to build your shaders and take most of the muck out of that, right? Absolutely. So you have a node-based system for doing all of your regular shader functions, and you can see a live preview, which I guess I should have added something to show you the live preview here. Good, oh yeah, we don't have any animated GIFs to show. Do it right now. But you can add your textures, you can call your functions, do everything that you would do, and get your shaders into a master node at the end, which the master node will be defined by the render pipeline that you're using. So at the end there, it's too small to see, it might say lightweight render pipeline. So whatever pipeline you've created, you kind of create these inputs that all your graph will go into, and then you have shaders that you can see. Like I said, at each stage of the pipeline, you can see what's happening as you're building it, so you can really play and get creative and not have to worry about writing tedious shader code. Now let's talk about post-processing. So many of the great visual effects you were seeing with the Book of the Dead are about the post-processing stack, and Unity has invested a lot of time and energy in the last few years on a great post-processing stack, and we've unlocked that all now with HDRP. So yeah, let's talk about Neon, Brad. So Neon was actually it's an interesting project. The director of the first Adam short film and the Book of the Dead was kind of in between projects. His name is Veselin Efremov. He was in between projects, and he wanted to do something creative, but all the programmers were busy wrapping up on the other projects. And so he said, okay, I'm gonna make something beautiful by myself. He went to the asset store, he downloaded a bunch of free assets, he grabbed the new post-processing stack, and he just built this scene. And it was really interesting kind of digging in and looking at his scene because he downloaded like a free fighter jet and kind of chopped the back and the wings off, and that's hanging right below that gas neon sign. And everything is sort of just like these little pieces from something else that he put together. And how he really made it shine was through the post-processing stack. So if we actually look, we can see some of the iterations, different things that you can do just by essentially moving some sliders around, changing some values. You can get completely different looks, dramatic, more noir. And I think at the end, we settled on adding all these post-processing filters, and I actually got to see this in VR the other day, which was really, really exciting. And I think on the last slide is what we wound up with. And it was really, really beautiful. He added rain, and it just kind of proved out the power of these kind of workflows for artists.
And Ves got this all off the asset store?
All the assets in here he got from the asset store.
That's amazing. All right, yeah, here's a great one too. In post-processing, right? We can see that we only have basic depth of field right now on this stuff, but with some post-processing effects applied, I'm gonna go back for a second. You see this? And you see how much more subtle and real that is. We've got vignetting happening. We've got ambient occlusion, if you know what that is, basically. It's things like on the gas cap here on the car in the front left. You can see those edges. I mean, those are done with an ambient occlusion technique where you couldn't possibly really calculate how those photons are bouncing around in the crack there. That's kind of amazing. Bloom and color grading just give you sort of tone and time of day stuff. Awesome. Oh yeah, and we've got some great debugging support for this stuff now in HD, right? Or the whole scriptable render pipe.
So I feel like debugging is almost sounds like a boring, kind of painful word for what we're doing here, but really what it is letting you see what's happening at every stage of the render pipeline, at what's happening with your materials, what's influencing what, and in some cases, your object might not look the way you want it to look. It just doesn't look perfect. And so we wanted, especially since you're going to be mucking around with a lot of this stuff yourself, and who knows what you did at late night programming or setting things up, you can come back, open the debugger, and look through and see what's happening. So here's an example of normals, showing just your normals on the object on the left, SSAO on the right. Split things up and see things in individual channels. And really, really exciting here is there's a bunch of debugging options that we've got hooked up already, and you can actually run the debugger in a runtime build and check on and off features to see what's affecting performance, change settings. So it works at runtime too, which is pretty exciting. And we made it extensible as well. So if you do something custom, it's easy to plug into the debugger.
All right, so we're going to show one more example of this stuff. We're showing off cool cinematic content, but as we know, VR is not just about gaming and cinematic, it's about all these other wonderful use cases. We worked with an agency called Tilt Shift, they're part of a group called Team One in LA, to create something for Lexus, which we showed off earlier this summer, and have a look at a video here. So this is a virtual Lexus that's shown in a virtual car showroom, and this looks like the real car, or as close to it as we've ever seen. This is in VR. And I don't know if you know it or not, but auto manufacturers are extremely exacting about how they want their products to look. It can't just look kind of real. It really needs to look like the real thing. You see that transparency and reflection? You saw the glint and the clear coat that Brad was talking about before? That's done with HDRP, and it runs in a Rift, and that is just so amazing. So we can't tell you how super excited we are about this. This is the coolest thing ever. Brad product manages this, so he's going to now tell you what we're planning on here, what's happening now, what's happening in 2019.
So I mean, this is just to kind of get you excited once again. So our 2018.2, which is out now, and the reason I'm showing you, why would I show you 2018.2 for a release that's already out, is actually the scriptable render pipelines are in a package. So that means that we can iterate on them outside of the major Unity release cycles. So in a lot of cases, if something is broken, something doesn't work right, you can go through, submit a bug, well, first of all, you could fix it yourself, or if you're like me and you'd rather just submit a bug and have someone else do it, then you can submit that, and it can be fixed without you actually having to move Unity versions. So for 2018.3, some of the things that I'm really excited about that I've already been playing with in the beta, which you can download today, is that Vfx Editor. Highly recommend checking that out. MSAA support, and that really kind of blew the lid off. When I first saw Book of the Dead in VR, I was like, this is incredible. I've never seen anything look as good. A week later, one of the engineers came and grabbed me and said, I've got MSAA working, hit the checkbox, and then I was like, okay, now this is the new bar. Now I've never seen anything that looks as good. So the roadmap and everything we're doing here, we're being transparent. All of this is open source, so you can grab it, change it, let us know what you want, what you need, and we can kind of develop this together.
You guys excited yet? Who wants to get their hands on this? Yeah. That is awesome. If you point your camera at this doohickey, it should take you to a GitHub gist, which gives you a bunch of resources. Who's the fellow who put that together?
Arturo Nerez.
Arturo, one of our evangelists, put together a set of resources, a great write-up and overview of this stuff, and also a link to the GitHub where you can get the packages, and you can go to town on this. Bradley and I are going to be outside. They'd like us out of the room soon, but if you want to do some Q&A after the session, we'll hang out outside. I don't know if we'll outlast John holding court for 2 hours after his session, but we'll do our best to hang out as long as we can until they kick us out. So we'd love to talk to you out there, and thank you all very much. Looking forward to working with you on this.